All right, so this is practice problems from 9.1. Our first one is NH3. Now, so we have one nitrogen and three hydrogens. First thing we're going to do is add up those valence electrons. Each hydrogen has one valence electron, so that's a total of 3. Each nitrogen, there's only one, has 5 valence electrons. So that is a grand total of 18 valence electrons. All right, we know that there has to be at least 2 electrons between each hydrogen and the nitrogen. And then there's a lone pair that rounds out the octet. We knew that nitrogen went in the middle because it is less electronegative than hydrogen. So it goes in the middle. Okay. Then we're going to do CH4. Again, we're going to add up the valence electrons. We have 4 hydrogens, so that's a total of 4 electrons. 1 carbon has 4, so that's a total of 8 valence electrons. Again, there has to be 2 between each hydrogen and the carbon, and so that gives us an octet for carbon, and each hydrogen has a full 1s sublevel. All right, so now we're going to do CH2Cl2. All right, so we have a carbon and a chlorine and 2 hydrogens. So it doesn't really matter if the H's are top and bottom or the chlorines are top and bottom, but it's going to look something like that. We have 4 electrons from the carbon. We have 2 from the 2 hydrogens. And we're going to have 14 from the 2 chlorines. So that's a total of 20 electrons. So we're going to put 2 between each pairing. And then that makes a single bond for each pair. And then we're going to put the lone pairs on our chlorines. Now remember, each chlorine started with 7, okay? And so it should have 8 now. So each chlorine has 8, carbon had 8, and each hydrogen had 2. All right? Now, with these, we're going to have at least one multiple covalent bond, like a double bond or a triple bond. So we're going to do the same thing. We're going to add up the number of valence electrons. We've got 4 from the carbon, and we have 12 from the oxygens. That's a total of 16. Now, if we do this the way we've been doing them, which most of the time works, we end up putting out all of our valence electrons, but we see that the oxygens have an octet, but the carbon does not have an octet. Okay? So we have to fix something. Okay? Carbon's not going to let the oxygens have an octet when it doesn't have an octet. All right. So if we had these lone pairs become double bonds, then carbon would have a octet. So let's see how that might look. If we draw as dot diagrams, it would look something like this. Might be a little easier to see if we draw as a structural formula, and it would look something like that. Okay? Now, for C2H2. All right, so we've got the 2 carbons, and then we have 2 hydrogens. Hydrogens always go on the outside. And we're going to add up our valence electrons again. We've got 2 hydrogens, so that's 2 valence electrons. We have 2 carbons, so that's a total of 8. That means we have a grand total of 10 valence electrons. Again, we know that there's going to be 2 valence electrons between each pair of atoms. And the hydrogens can't have any more valence electrons, so those lone pairs have to go on the carbons. But if we look at this, all right, the hydrogens have a full outer shell, but the carbons do not have octets. And again, that's not what we're going for here. They want that octet. So instead, what if we had one double bond between the two carbons? Well, now each carbon has 6 valence electrons. So that's still not an octet. So that's probably not the answer either. Okay. So that first one, I made a mistake. It does have an octet. Okay. But then the second one does not have an octet. So we got to fix this. And one way to do that would be with a triple bond. Okay, so if we have 3 pairs of electrons being shared between the two carbons, now each hydrogen has a full outer shell, and each carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So that would be the structure that is most likely. All right, so now for this last one, we have chlorate, ClO3. So we add up our electrons. Chlorine has 7. Each oxygen has 6. That's a total of 18. But there's also a minus sign there. And remember, the minus sign tells you how many electrons they gained. So we gained 1 electron to become negative. So that is a grand total of 26 valence electrons. All right. Now, we're going to put a pair of electrons between each oxygen and the chlorine. That used up 6. Now we're going to put lone pairs around the oxygens. And if we count that up, each oxygen has 8. That's 24. And then we have a lone pair on the chlorine that makes 26. So each oxygen has an octet. The chlorine has an octet. And we've used up all 26 valence electrons.